Okay, so today I'm going to be showing you how to manipulate, graph, and find key points of ellipses and hyperbolas. So first I'm going to start with the ellipse. So what I did to turn the general into standard, right here I wrote all these step by step out. So first I factor out the 9 and 81 by dividing. So how I did that was I divided the x's by 9s and I divided the y's by 81s, so that if I were to factor them in, they would go look like that. So once I factored them out, which I basically divided them, I got 9x squared minus 16x over 9. And then I got 81y squared plus 4y over 81 is equal to 171. Next, I completed the square, which was a skill that I learned from last year. So what I did was I took what times what is equal to x and what times what is equal to y. So what times what is negative 16 and what times what is 4. So I know a negative plus a negative is equal to a positive, but I could not figure out for the life of me what to do for this that was the same. So I end up just doing negative 4. So I know my signs are wrong, but it's the steps that matter. So for this, I went ahead and I did x minus 4, and then I filled it out. So x times x is x squared, and then negative 4 times negative 4 is negative 4 squared. Don't mind the x, I didn't mean to put that there. And then, I'm sorry, x times negative 4. I didn't mean to put the squared, that's what I meant. And then, x times negative 4. And then negative 4 times 4 or whatever is equal to negative 16. And then I wrote out basically the top part, which was x squared minus 4. And then I did that for this side. I did y times y is equal to y squared, all of that. And then I got y squared plus 4. So then I use these for my equations, and then I put I put the factors underneath to divide by. And then after I divided them by their factors, step 3, divide them by their factors. And then step 4 is you multiply the original factors by the fourth number in the box. So what I did was, for negative 16, I multiplied 9 by negative 16 to get negative 144, and then I subtracted that from 171, and then I did 4 times 81, which is 324, and then I added that because it was positive, so I got 297 at the end of my ellipse. And then after that, I got my equation, so, which is right here. So after that, I have to identify the I have to identify the vertices, and co-vertices, and then identify the major and minor area axes of the ellipse. So I wanted to show you guys this picture that I have on my thing to kind of explain it better. So the minor axes is the x-axis, and the co-vertex and the minor axes are always going to be horizontal, and whatever that number is, it's going to be the smaller number out of the bunch, which I'll show you in a second. And then the major axes and the vertex is always going to be the vertical, going up and down because it's the bigger. And what I mean by that is you can find these numbers by looking at what they're divided by. So the square root of 9, we have to take the square root. So the square root of 9 is 3. The square root of 81 is 9. And 3 is a smaller one out of 3 and 9. And 9 is the bigger one. So our minor axes and our co-vertex would be 3, or it would be on that line. And then our major axes is 9. And then our center is just these points with the signs flipped. So I got 4 because I had to flip the sign. So it's 4, comma, negative 4 because I had to flip the sign. I'm going to show you what this graph looks like. Whoops, wrong paper. Oh no, I need to find my paper. Hold on. All right. So I wrote all these steps out because I thought it would be easier for the ellipses. And yeah, so I wrote that out right here. And then I graphed it. So our center is 4 times -4. So I went, so x is 4. So I went across the x-axis 4 times. And then I went down 4 since it's -4. To find the to find the minor vertex, and the I went, what was it? I went over 3 from the center. So I went 1, 2, 3 to find one end, and then so I added 3 from the center, and then I subtracted 3 from the center. And then I did the same thing for the major, but I did it vertical. So I went up 9 and down 9 to find the top and the bottom of that. So I plotted the center, and then for step 8 for the minor axes, go 3 left, which is what I just explained. And then I do the same exact thing for the major. So that's it for the ellipses. And then for the hyperbola, let me pull out my notes for this. I didn't write them step by step because it's basically the first parts are what we did for that. So I went ahead and I factored out my 16 and -49. So 16 and then that, and then I should have wrote under here as well. But I forgot to. And then is equal to -144. I completed the square. Because these were weird numbers, I got decimals, but they worked out in the end. So I got 2.44 because 2.44, or the square root of 6 is 2.44, and the square root of 8 is 2.82. And then I did the same thing. So I know I messed up all my right side of my equation because with hyperbolas, it's always supposed to be equal to 1. Unfortunately, I cannot find my notes to my recent hyperbola homeworks, and I can't figure out how I got it set to 1. So we're just going to ignore that because I don't know what I did to do that. I treated it like the last equation, even though that's not right. I cannot figure out how to set it to 1. Anyways, after I went through all these steps like I did in my last one, here's what I got. Minor and majors are the exact same, so it's again square root of 16, which is 4, and the square root of 49, which is 7. And now here's the difficult part of hyperbolas. So they're gonna look a lot. Let me pull up my Desmos. My hyperbola looks like this, and I try to replicate it on the screen. So basically, it's, from what I've learned, is the inverse of a circle, and that's why it goes outside. And you determine if it goes outside either on the horizontal, so if it goes out this way, or if it goes out like top and bottom, like that, by if it's X or Y in front. So because it like goes out this way and not this way is because the Y is in front in the equation. If it were going to be X in front, so like you see Y is first instead of X, if this was flipped, it would go like that, if that makes sense, if you get what I'm trying to say. So basically what I did was I had to find the isotopes and find the equations for that. So I plotted my lines or my dots for my minor and major axes exactly like I did. However, I wrote down the exact coordinates so that it would be easier for me to find the isotopes. So I drew a circle, or a square around my circle to find my isotopes, and I picked 2 corners. I ended up picking the top corners because those were easiest in my opinion. And what I did was I made sure if I was going along the x-axis, I would keep the same y plot since we are at the point 9.44. But I added onto my x plot however much we went up. And because we went up 7, I added 7 to my y plot. So 2 plus 44, or I'm sorry, 2.44 plus 7 is 9.44, and that's how I got this corner. And then if you want to go to this corner, negative 1.18, I'm sorry, since I'm on this x-axis, or this, I'm along, like my dot's going to be on this x-axis, but up near this y-axis, I did 2.44 plus 7 So the only thing differing are my x's because they're on different sides, but they're on the same x-axis, if that makes sense. Because they stay here, but they're different here and here. So I got negative 1.18 and then 9.44 because that's where they were plotted at. And then to find the equations for this, what I did was this. So I started off with the left top corner, and I'm going to show you what I did for that. So to find the isotopes, it's the change in y divided by the change in x. So I wrote it out. I used my center point and I used my left corner point. And I put my center points first and then my left corner point second. And then, so it's change in y and change in x. So I did 9.44 minus 2.44. And then I got 7. And then I did negative 1.18 minus 2.82. And I got negative 4. And then I plugged that into y is equal to mx plus b. So what I did for this was I put 7 over negative 4 for m. And then I took one of my coordinates. So I ended up using the center coordinates, I believe. I used a set of coordinates for y and x. So I plugged the y into y and I plugged the x into x. And then I solved from there. So I just, found what 7 over negative 4 times 2.82 was, which was negative 4.93. Then I subtracted, sorry, let me go ahead and fix this real quick. Plus b, I don't know why there's an equal sign there. Plus b. So then I subtracted, I just did basic algebra, or I'm sorry, I didn't subtract. I took the 4.93 away from the right side of the equation. In order to do that, since this is negative, I had to add it, which meant I had to add it onto this side. So I got 7.37 is equal to b. And then on this side, to find that right isotope, what I did was the same thing, essentially. So it's 9.44 minus 2.44 is equal to 7, and then 6.82 minus 2.82 is equal to 4. So it's this, but the denominator is negative. Plugged it into y is equal to mx plus b. And I went and did the basic algebra like I just showed you, and I got negative 2.49 is equal to b. And yeah, that is my manipulating ellipses and hyperbolas.